Good afternoon. Thank you for attending this talk. My name is Bergur Sigfusson. I'm a geochemist at Carbfix, and I'm going to give you a brief overview of our project, Geothermal Emission Control, or GECCO. Now, GECCO is a large consortium of more than 17 partners across Europe, and we are both industrial and academic partners. And we have the common aim of trying to minimize emissions from geothermal power plants. And I'm going to give you a short overview of what we have been doing for the last years and what we will be doing in the coming year. This is what I'm going to talk about. So why GECCO? Why did we establish this project? Give you a brief overview of the project description, the aim and objectives, and give you a presentation of the overview. Who are we? Project timeline, what technologies we are demonstrating and doing feasibility analysis on, and then give you a little bit of update on the progress and the future of the project. Now, why GECCO? The International Panel of Climate Change states that reports from them state that climate goals will not be reached without a large-scale CCS. At least 100 gigatons of CO2 will need to be removed permanently from the circulation, from the atmospheric circulation to reach the climate goals. And one thing that is apparent is that injection of supercritical CO2 into sedimentary formations has been successfully operated for years, and clearest example is the Sleipnir project in Norway. Geological conditions, however, they are not always suitable for the injection and storage of supercritical CO2, because the CO2 has when CO2 is on the gaseous phase, it has the tendency to rise to the surface. And therefore, Carbfix was developed, which is a method that can expand the applicability of CCS to new regions. What we do there is that we co-inject CO2 and water and make sure the CO2 is fully dissolved in the water when it enters the formation. Therefore, we have killed the buoyancy force of CO2 gas, and this fluid is usually denser than the water in the storage formation, so the fluid has the tendency to sink rather than to rise to the surface. Then later on, when this fluid reacts with the rocks, in the case of Iceland, mainly basaltic rocks, the basalt liberate cations that react with the CO2 to form carbonate minerals. And this is what we have been doing at Hellisheiði geothermal plant in Iceland since 2014. There, the exhaust gases that we extract from the condensers of the geothermal turbines, they are compressed into a column, like an absorption column, where CO2 and H2S are preferentially dissolved in condensate from the same turbines. And there, because of elevated pressure, large portion of the CO2 and much larger portion of the H2S, which is more soluble in water, dissolve in the water, and we take this gas-charged water and inject it with other reinjection water from the power plant into the reservoir. And there, in the high temperature reservoir, carbonate and sulfide minerals are formed. And as I said, we have been operating this since 2014, and up to now we have injected and mineralized more than 70,000 tons of CO2. But GECCO, so this was developed in basaltic environment, but we are interested to know where are the boundaries for carbon mineralization as storage solution. So which rocks are fit for it and which are not. And so therefore, we want to advance the method by defining the boundaries for carbon mineralization. We want to we want to develop this method and make sure it is only reliant on water, which in this case, for the geothermal plants, can then be supplied from the power plant itself. And this application of the method makes sure we minimize the usage of chemical solvents such as amines, for example, to reduce the emissions from the power plants. We aim to test and demonstrate in 4 countries in 5 geothermal systems and 1 system which is a sedimentary aquifer. So what we want to do? We want to lower the emissions from geothermal plant by capturing them for either storage or reuse. We want to essentially increase the geothermal competitiveness, and we want to make sure that the capturing involves minimum capital expenditure as well as energy and resource demand. We want to be able to turn captured emissions into commercial products, allowing for cost reductions through increased revenues of the plants. And we hope that the solutions we are developing will be available to, of course, both the geothermal industry and perhaps some power industries and heavy industries towards lowering their emissions, and in particular in areas that have not been considered before because they were too far away from storage sites. The consortium is composed of 18 partners. We are 4 industrial partners, 1 SME, and 13 are in research and development facilities and organizations and universities. The consortium is approximately 40% women, but a large part of the leaders of the consortium are women, and we have external advisory board as well, which is mainly from Europe, but we also have partners from New Zealand. And here you see the list or the logos of all the different identities that compose of this project. And you can see the demonstration sites, they are marked with a star. Here in Iceland, actually, we have 3 sites. We have 1 in Bochum. 1 site that we were working on is in Castel Nuovo in Italy, and then 1 in Turkey. Here you can see the overall project timeline. We started the project in the autumn of 2018, and this was done by collecting all the data that we did, doing the basic design of the systems that we wanted to demonstrate, and collect all the information of the sites themselves, both in terms of the power plant facilities and the resources available, but also in terms of the reservoirs that we were going to inject gas into. Then in 2020, we started to do the final design and engineering of our injection systems and capture systems. And then in this summer, 2021, we started up our first and most simple demonstration project, but we will be demonstrating and starting different parts of from different partners throughout this year and into 2022. And then we aim to be testing our systems until the end of the project, and we will do the wrap up and all the analysis of our data until the end of the project, which will be in September 2022. Now, if we go a little bit into the technologies that we are testing, in Hellisheiði and Nesjavellir high temperature site in Iceland, there we have started with reservoir modeling of the Nesjavellir site, where we are going to develop and essentially improve our gas capture method, and by elevating the temperature compared to what we have been doing in the past, and this will in turn decrease the water demand and the capture efficiency of our process. We have also been doing a large amount of feasibility studies on different purification technologies with the aim of being able to demonstrate them at the Hellisheiði power plant. In Nesjavellir, our other plant, we are going to inject CO2 and H2S into the ground, approximately 1,000 tons, and this will 1,000 tons per year, and this will start now in January 2022. We do monitoring, both prior or baseline monitoring and monitoring during our activities to be able to quantify what we are doing. In Castelnuovo in Italy, there the plan was to demonstrate a closed loop testing unit of a discharging well, where essentially a production well, all the emissions from the production well were to be installed into a closed unit, and everything was supposed to be injected into the ground. This was supposed to be started this year, but unfortunately permitting issues prevented us from implementing this year. So what we have done here is that we have already done the reservoir modeling and characterization, and we are finalizing feasibility studies for this site. To compensate for our loss of Castelnuovo from this project, we decided to demonstrate this closed loop system anyway. So there we went into a well that was available in Iceland, where we can supply steam to the testing unit, and then we can complement for lack of CO2 in this particular steam from this site just by commercially buying CO2 and then mixing it to the steam phase to be able to mimic essentially the gas to steam ratio of Castelnuovo. And this is something that we are working on now with colleagues mainly from Storengy and Graciela Green Power, and there the aim is to start this project next spring. Here we have done like a small reservoir modeling. We want to demonstrate a closed loop, the CO2 injection, where we'll do quite a lot of measurements on how it's best to inject very high concentrations of gas into the ground, and we will, of course, similarly to the other side, we will do the monitoring of the whole system. In Kızıldere in Turkey, our partners at Sorlu, they have been, and also with their partners Metu, they have been doing similar things, but not quite the same. So a reservoir modeling has been done for the geothermal reservoir there. There, Sorlu aims to capture part of the CO2 from the power plant. This CO2 will then be compressed and co-injected with water into the reservoir, and all at the same time monitoring will take place to investigate the fate of the CO2 in the subsurface. And this will also give our partners valuable experience on how to capture and treat the gas on the surface. In Bochum in Germany, our partners at Fraunhofer will be or have been doing the reservoir modeling of the reservoir, and this is not a geothermal reservoir, this is rather a cold sedimentary reservoir. But here what they have done is they have done the reservoir modeling, and then the aim is to inject small amount of CO2 into the reservoir and investigate its fate in the ground. But this is a slightly different site from all the others which have active power plants on site, in terms that this is a pure experimental site, and then all the scale of operations is considerably smaller than with the power plants themselves, although we consider it to be, or we make sure that it is sufficiently large for us to be able to see what is going on in the subsurface. Now, just a recap of what we have done. So we started with the infrastructure characterization and geological investigations in 2018 and 2019. We finished the geological characterization and reservoir modeling in summer 2020. We finished the injection well modeling in 2021. And nowadays we are commissioning our systems. We are also doing corrosion monitoring in selected sites. We are also looking at some innovative chemistry monitoring in other sites, and these systems, the simple systems, they are being installed at the moment. Many of our equipment and systems are in procurement or some stages of construction at the moment, and then we aim to commission everything now in summer 2021, 2021 until early winter 2022, where the last of our equipment will be started. And then during the final months of the project in summer 2022, we aim to, of course, evaluate our demonstration campaigns and report on our findings. And with that, I am open for questions. Thank you very much.